Welcome to The Explainer. Today, we are unlocking a fundamental concept that, believe it or not, powers almost every single database you interact with every day. We're talking about keys. They are the invisible engine that keeps our digital world organized, and right now, we're going to see exactly how they pull it off. All right, to really get this, let's start with a problem. I want you to imagine a huge university database, just packed with student records.
So you've got thousands, maybe even millions of entries. How in the world can you be absolutely positive you're looking at the right person, especially with a super common name? It's a recipe for disaster, right?
And here's what that looks like. Without some kind of unique identifier, the database is having a total identity crisis. I mean, are these two different people who happen to have the same name? Or did someone just mess up and enter the same person twice? Based on this info alone, there's just no way to know. This exact chaos is what database keys were invented to solve.
So how do we fix this? How do we give every single row of data its own unique, stable identity? Well, we give it an anchor.
And that anchor has a name, the primary key. The easiest way to think about it is like a unique serial number, or maybe a digital fingerprint for each row of data. It's a really strict rule that says, hey, this value has to be one of a kind for every single record. No exceptions, and definitely no duplicates.
And boom, just like that, the problem is completely solved. See what happened? By adding that simple student ID column and calling it the primary key, all the confusion just vanishes. Now we know for sure that student 101 is our physicist Jane Doe, and student 254 is our historian Jane Doe. Every single record is now perfectly, uniquely anchored. So this is the really crucial part. A primary key has two rules you just can't break. First, it has to be unique. And second, it can never, ever be empty. You can't have a missing value. These two things together guarantee that every record has a stable, totally reliable identifier.
Okay, on to our next challenge. Now that all of our data is nicely anchored, how do we start building connections between different sets of data? Right, so we know who our students are in one table, but what about their classes? We need a way to link our students table to, say, an enrolled table. We need to build some kind of bridge between them so we can create a meaningful relationship. And this is the perfect job for the foreign key. It is the exact bridge we need. A foreign key in one table is basically just a copy of the primary key from another table. It creates this direct link that the database can actually understand and enforce. Now check this out. Here's that bridge in action. Take a look at the student ID column on the right in the enrolled table. That's our foreign key. Now, its job isn't to be unique in this table. You can see student 101 is listed twice, right? No, its job is to point back to the unique student over in our main students table. It's how we know exactly who is taking which class.
Now, this connection, this bridge, it isn't just a friendly suggestion. The database actually enforces it through a concept called referential integrity. All that means in simple terms is that the relationship between tables has to stay consistent. You can't have an enrollment record for a student who doesn't exist. That bridge has to lead somewhere real.
So, for example, what happens if we try to delete a student? Well, the database looks across that bridge, and we get to define the rules. We can tell it to just reject the deletion to prevent having these orphaned enrollment records, or we can tell it to cascade the change, which would automatically remove all the enrollments for that student, keeping everything neat and consistent.
So we've seen that keys can identify and connect data, but their true power, well, it goes even further. You should really think of them as a power tool for database performance and design.
Okay, first up, performance. Think about finding a topic in a giant textbook. Are you going to read every single page from the beginning? Of course not. You're going to use the index in the back. Well, keys are what allow a database to build that index. It creates this super efficient structure that lets it jump almost instantly to the correct record. This is why searching for something by your unique user ID is lightning fast, while a more general search can feel slow. It's a total game changer.
Second, let's talk about good design. Keys are absolutely central to a process called normalization. And all that is just a fancy way of saying we're organizing our data to get rid of repetition. By using keys to split data into related tables, we don't have to type out Jane Doe's name and her major for every single class she takes. We just use her key. This keeps our data clean, consistent, and way more efficient.
So let's bring this all home. Let's talk about why this actually matters to you, probably every single day.
You know, the big takeaway here is pretty simple. Keys are the invisible architecture of organized data. They are the anchors, they are the bridges, and they are the power tools that turn what would be a chaotic sea of information into a structured, efficient, and reliable system that just works. And you see this everywhere. That unique order number you get when you buy something online, that's a primary key. The system uses it as an anchor to find your specific order out of millions. And when that same system pulls up your shipping address from your customer profile, yep, it's using a foreign key as a bridge to connect that order to you.
So the next time you track a package or log into an app or do pretty much anything online, see if you can spot the anchors and bridges working silently behind the scenes. It's this simple but incredibly powerful idea, the database key, that truly makes our complex digital world possible.